So let's focus on differentiating for now. We said that the velocity is the rate of change of displacement, and the acceleration is the rate of change of velocity, or dv by dt. So we can link together the displacement, the velocity, and the acceleration like this. If you look at the first equation, that says that to get velocity, we do ds by dt, so we're differentiating the displacement. So if we differentiate the displacement, we'll get an expression for the velocity. If you look at the second equation, it says if we do dv by dt, if we differentiate the velocity, we'll get the acceleration. So if we have an equation which describes the displacement, so we have, I don't know, s is 3t squared plus 5t, for instance, that says how the displacement changes over a range of time. So at t is 1 second, you can say the displacement is 3 plus 5 is 8 meters. Okay, so that what will happen is we'll get an equation for the displacement. We can use that equation to give us a new equation for the velocity by differentiating, and we can get an equation for the acceleration as well by differentiating again. I'll show you plenty of examples of this in the next few minutes. So here's the first one. The displacement of a particle from fixed origin is given by s equals 6t squared minus 4t plus 3, where t is the time elapsed in seconds. So here we've got an expression for the displacement. So if I give you a time in seconds, you'll be able to work out the displacement from the origin at that time. That's what we're going to do in this quick first question here. It says find the displacement when t is 3. Well, my displacement s, all I do is substitute in t is 3. So substitute in t is 3. That gives me 54 minus 12 plus 3, which is 45. So displacement is 45 meters. Okay, so we can use that expression to work out the displacement at any time. And now we want to find an expression for the velocity. Well, if you remember back, we said to get from displacement to velocity, we differentiate. Okay, and that's because v is ds by dt. So we differentiate the displacement, we get to the velocity. The big thing to remember is the order these things happen in. So displacement differentiates to give velocity, differentiates to give acceleration. Okay, so that's the order it goes in for differentiation. So if we want an expression, we can say v is the displacement differentiated. So it's going to be, I'm going to differentiate 6t squared minus 4t plus 3. That was our expression for the displacement. If I differentiate that, if you remember our lessons on differentiation, probably seems like a long time ago now. If we differentiate the first bit, we get 12t. The second bit, we get minus 4, and plus 3 disappears. If you've forgotten how to do that, or if you're struggling with that, go back to the lessons on pure maths on how to differentiate, and it'll clear that all up. I don't want to go through that now because it'll take a lot of time, so I'm just going to assume you're happy with this differentiation for now. Anyway, there is an expression for the velocity. It's 12t minus 4. So if I want to find the velocity of the particle after 6 seconds, I can do that now because I know v is 12t minus 4. If I substitute in, my t is 6. And that gives me 68 meters per second. Okay, so it's pretty quick. Okay, so once we know the expression for the velocity, we can find the velocity at any time we like. Let's have a look at another example. So this time we've been given the velocity in terms of the time. So find the velocity of the bird at t equals 6. Well, we've got this expression for the velocity. So what I'm going to do is take that, and instead of putting t in, I'm going to substitute in 6 everywhere I see t in the expression, because I'm interested in the velocity at t is 6. If I work that out, I'll just chuck that in the calculator. It's 49 meters per second. Okay, so I can work out the velocity really easily because I've been given the expression in the question. The next bit says find an expression for the acceleration. Remember, to go from velocity to acceleration, we just differentiate. Okay, and that's because acceleration is the rate of change of velocity. It's dv by dt. It's how fast the velocity is changing. So acceleration is dv by dt. So I need to differentiate the expression for the velocity, which was 5 over 2 t squared minus 7t plus 1. And if I differentiate that, I get 5t minus 7, and that 1 disappears. Okay, there's my expression for the acceleration. It's 5t minus 7. So find the time at which the bird has an acceleration of 2.5 meters per second squared. Well, I know the expression for a now. I know that a is 5t minus 7. They've told us what the acceleration is. It's 2.5, so I can substitute that into my expression and just solve it from there. So if we do a bit of rearranging, that gives me t equals 0.53 seconds. Okay. So this time, instead of saying what's the acceleration at a certain time, I'm going to say what time does it have this acceleration. It's just as easy. We just substitute in for the acceleration instead and solve for the time.